All right, guys, 12-3A is what we're doing today. And it's working with 2x2 matrices. So we're just going to be dealing with 2x2s today. In a couple days, we'll be doing 3x3s with some of the same stuff. But what we're going to be doing is figuring out how to find the inverse of a matrix. Not all matrices have them. Most square matrices do, but not all square matrices do, but a lot of them do. So we're going to start with a few definitions. The first is, what is a square matrix? My guess is you can probably stop and think through what this might be. Basically, a square matrix means the number of rows equals the number of columns. Okay, number of rows equals the number of columns. So that would be a 2x2, or a 3x3, or a 4x4, so on and so forth. Those are square matrices. So like I said, 2x2s today, 3x3s will be coming. Second thing, definition-wise, is we're going to be talking about the multiplicative. Wow, those letters are not showing up, are they? Multiplicative identity. Sorry, we'll get to inverse in a minute. The multiplicative identity. Struggling, guys. We talked about this in the first week of school. Remember, we said if you take a number and you multiply by 1, you will always get that number back. So the identity matrix, like for a 2x2, okay, so I of 2 is saying the identity matrix for a 2x2 is 1, 0, 0, 1. Any matrix that you multiply by that number will get you 1. Sorry. So this is the multiplicative identity for a 2x2, or for a 3x3. It looks like this. Okay, so you can kind of see what's happening. If you notice, you have a diagonal of 1s that goes from the top left corner to the bottom right corner, and then everything else is 0s, and that would just keep growing the more, the bigger the matrix that you would be working with. Okay, so that's multiplicative identity. Then we're also going to talk about the multiplicative inverse. And for multiplicative inverse, basically this is saying that a matrix times its inverse, that's a -1, sorry, so that's the inverse matrix, right, will equal your identity matrix, okay? Think of it like this, right? If I take the number 2 and the inverse of 2 is 1/2, it equals 1. Well, this is saying a matrix times the inverse matrix will equal essentially the 1 for matrices, which is these guys up here. Okay? So we are going to do some examples with all of this information. The first thing we're going to do is we are going to show or verify, they might say it either way, that A and B are inverses. Okay. In the book, they're going to say you need to do it both ways. A times B equals I, and then prove it by showing that B times A equals I. You don't need to do that. We're just going to have you do it one way. So here's our first setup for this. Let's say that we have a matrix A, and I'm just going to set it up already multiplying. So matrix A is 2, 3, 1, and 2. And then we have this matrix B, and we're going to multiply them together. 2, -3, -1, and 2. Okay, we want to show that A and B are inverses. Okay, that's what we're trying to show here. So we want the identity matrix to be our result, right? Well, when we multiply these, remember we do the top row and the first column for our first slot here. So this would be 2 times 2 is 4, plus 3 times -1 is -3. Okay, then we do top row with second column. So 2 times -3 is -6, and 3 times 2 is 6. Okay, then we do the bottom row with the first column. So 1 times 2 is 2. 2 times -1 is -2. And then we do the bottom row with the second column. So it's going to be 1 times -3 is -3, plus 2 times 2 is 4. Okay, so what we get from this, 4 plus -3 is 1, -6 plus 6 is 0, 2 plus a -2 is 0, and -3 plus 4 is 1. So you notice that we get the identity matrix. Okay, so that's our verification. Now this is the proof, okay? I don't want to see this and then you just write this. I need to see that you know why it's going to become this. Sometimes it won't become that, but I need you to show the why. So show me this stuff, okay? All right, how about this one? Same thing, verify here. So matrix A is -2, -5, -3, and -8. Matrix B is -8, 5, 3, and -2. Okay, so again, if we do the top row, first row with first column, right? So our first one here, -2 times -8 is 16, plus -5 times 3 is -15. Second one, we have that first row with the second column. So -2 times 5 is -10, and -5 times -2 is +10. Then we have the second row with the first column. So -3 times -8 is a +24. -8 times 3 is a -24. And then for our last one, it's the bottom row with the second column. So second row, second column, we would do -3 times 5 is -15. And then -8 times -2 is +16. And again, if we simplify this, we get 1, 0, 0, and 1. So this is our verification. Again, I want to see your work on this. I want to know that you know how to multiply these matrices, okay? All right. Next, part B here. We are going to talk about an inverse. And the first thing you need to know with inverses is called the determinant. And this determines if the matrix has an inverse. Okay, determines if the matrix has an inverse. So we would say this, first of all, if the determinant of whatever your matrix is, if it equals 0, this means no inverse. Okay, so if you solve for the determinant and your determinant is 0, it's no inverse. If it's any other number, 16, 34, 1 million, then there is an inverse. Okay, so anything but 0 has an inverse. But if your determinant is 0, there is no inverse. Okay, so here's how you find the determinant of A. Let's say A is the matrix A, B, C, D. Okay, the way we find it, so the determinant of A will always be A times D, so the diagonal starting at the top, minus the diagonal going the other way, B times C. Okay, that's what helps you find your determinant, and your determinant is always going to be a real number. So 16 or negative 1/3, actually positive 1/3, it could be negative 1/3. So your determinant will always be a real number. It can be a fraction, can be a whole number, but it's a real number. All right, so here's what we're going to do. We're going to find the determinant, see if that makes sense to you. So example 2 is find the determinant. Okay, so here's your first setup. Let's say our matrix is -3, 4, 2, and -5. Okay, if I want to find the determinant of that matrix, we're just going to call it matrix A for now. Okay, my determinant would be to go this way. So -3 times -5 is a positive 15, and subtract this way. 2 times 4 is 8. So my determinant is 7, which means this has an inverse, right? I didn't get 0, so it has an inverse. All right, how about this one? If I go -4, 2, -6, and 3. Okay, if I want the determinant of this, we'll just not put a letter this time because I didn't put a letter out in front. If I want the determinant, again, I'm going to do this, which is -12, minus this. So -6 times 2 is a -12. You're subtracting, so minus a negative becomes plus a positive, which means my determinant is 0, which means there is no inverse for this one. So this is, yes, it has an inverse. This one is no inverse. It's a terrible no, sorry. Okay. Okay, so let's move on from here. We're going to say let A equal that same matrix that we were just using, A, B, C, and D. Okay. As long as, so if the determinant of A does not equal 0, okay, so as long as your determinant is something other than 0, we can find the inverse using the determinant. So your inverse is, and then it's this, the inverse of matrix A is 1 over the determinant of A times, and now here's where things get a little bit different, okay? We're not multiplying by A, we're multiplying by a different matrix. We're gonna swap A and D, so this is gonna be D and this is gonna be A, and then we're just gonna change the signs of the other two. So B stays in the same spot, but now it's the opposite of B, and C stays in the same spot, but it's the opposite of C, okay? So this is how we're gonna find an inverse, all right? Another way that you could think of it, maybe this makes a little more sense to you. If you like it better this way, you can think of it this way. Basically what we're doing is we're taking 1 over the determinant, we're swapping these, and we're making the opposite of those, okay? Okay, so we are going to do example 3. And we are going to find the inverse. So put it all together of the matrix. Okay, we're gonna find the inverse of this matrix. So we're gonna do 3 of these, and then that's it for this lesson. Letter A. If I tell you that M, matrix M, is -2, 2, 5, and -4. Okay, and I want to find the inverse. Okay. We start by finding the determinant. So let's start there. The determinant of M. And remember what we do for that. We multiply diagonal, so that is 8. And we subtract the other diagonal. 5 times 2 is 10. So our determinant is -2. Okay, so now you look at the formula for this. We're plugging in to this right now. So it's going to be the inverse of M equals 1 over our determinant, which is -2, and then times, and now we have to do our swapping. So we're going to swap, let's switch the color here. We're going to swap these two, so it's going to be a -4 here, a -2 down here, and then we're just changing the sign of the other two. So these were both positive. I'm going to make this a -2, and I'm going to make this a -5. Okay, so now your job is just to multiply that. So 1 over a -2, you're multiplying by a -1/2. So our inverse would be -1/2 times 4 is 2. -1/2 times a -2 is 1. -1/2 times 5, I would just leave that as 5 halves. You can call it 2.5 if you like that better. And then 1 over -2 times -2, again, is 1. So this is your inverse of M. Kind of fun, right? All right, letter B. Let's do another one. So let's say I tell you that A is 3, 9, 2, 6. Okay. We start by finding the determinant. Okay, so the determinant of A, remember how we do that? We take the diagonal, multiply it together, so 18 minus, and then this diagonal, 9 times 2 is 18. So our determinant is 0. Now remember what happens when our determinant is 0. What does that mean? Your inverse does not exist. If your determinant comes out to 0, that's the only time that you can't find an inverse. Okay? So that one's quick. Okay, maybe you want to pause and try this one yourself. That's up to you, or I'm going to do it right now if you don't want to pause. So let's say we have the matrix C, -2, -5, 1, and 3. Okay, and we want to find the inverse. So to find the inverse, we start by finding the determinant. Remember, determinant is multiply here, so -6 minus multiply here, -5. That's plus a positive then, so -6 plus 5 is a -1. Okay, so that's our determinant. And now we are going to find the inverse. So finding the inverse of C, is going to be 1 over our determinant, so 1 over -1, times, and now we do our swap. So we're going to swap these two guys. So this is going to be 3 up top and -2 down below, and then change the sign of these two. So this is going to be a +5 here and a -1 here. Okay, and this is -1, right? So basically you're taking the opposite of everything. So this is going to be a -3, a -5, a +1, and a +2. And that is the inverse of that. Okay. And that is it. That is 12.3a. Next lesson, we're actually going on to 12.4a. And then we'll jump back to 12.3b and 12.4b. It just makes a little more sense to do them together that way. So enjoy.